Simplifying radicals. There can be no perfect square factors of the radicand remaining. In other words, there can't be any factors of this that are perfect squares, and we'll get to what that means in a second. We also can't have fractions that are under the radical. So if you have an entire fraction underneath the radical, it's going to tell you you need to simplify it. We also can't have a radical in the denominator. So if you have a fraction and you have a square root on the bottom of that in our denominator, that needs to be simplified. And simplifying radicals is just like simplifying fractions. It needs to be done in order for your answer 100% correct. So the first thing I want to do is I want to list what our perfect squares are. Because if you ever struggle with square roots, it's probably because you're not 100% certain what your perfect squares are. So I just made a short list on the top of mine. I said, these are what I mean by perfect squares. And what I mean by perfect squares is basically if I have 2 squared, that means 4 is a perfect square. Because what's the square root of 4? 2. All right? Our perfect squares are things that you take the square root of and they come into a nice even number. Yeah, I see that. All right, and I'm going to list a couple other ones that should be key that you don't have to think about. So 3 squared equals 9, so 9 is a perfect square because the square root of 9 is 3. 4 squared is a good one. That gives us 16. 5 squared gives me 25. And I think I just stopped at 6 squared equals 36. Now it's important to have these kind of in your head. And this is also a good section to have your calculator for. Because especially when we get to like big numbers that you need to simplify, it's always a good idea, if you don't know what perfect square goes into it, just take that huge number, divide it by 4. Divide it by 25, divide it by 36, divide it by 16, and just see what goes into it evenly. That's where your calculator comes in handy. You can just check real quick to see if any of those basic ones go in. So the first one we have to simplify is square root of 64. And what's the square root of 64? Who knows that? Mazin? Plus or minus 8. In this regards, because we're in geometry, we're going to disregard the plus or minus. Okay? So I saved you half the work. We no longer have to do the negatives right now. All right? It's always good to keep in the back of your mind because when you go back to Algebra 2 or pre-calculus or whatever, you have to go back to the plus or minus. But in geometry, we don't have negative distances. So all we're going to worry about is that the square root of 64 equals just 8. We're just going to stick with 8. And I put a little note to myself in case I didn't remember this. And that's since 8 squared equals 64. So 64 must be a perfect square. All right? So it's just 8. And if you didn't realize it was 8, make sure you have this note down. All right, square root of 32. 32 is not a perfect square. If you plug in square root of 32 in your calculator, it's going to come out to some decimal. What can we do with that? I still want to simplify it. Can I simplify it, I guess? From memory? Because we should have done this once or twice before. Yeah?
Would you divide it by a perfect square?
Yep, I would divide it by a perfect square. And does 4 go into 32?
It does.
Does 9 go into 32?
No.
Does 16 go into 32?
It does.
Well, that's got to be the biggest one because 25 can't go into it, 36 can't. So I'm going to say, well, 4 works and 16 works. I'm going to pick the biggest one that goes into it evenly. So I'm going to rewrite square root of 32 as square root of 16 times 2. And the cool thing about radicals is I can now pull this apart. If I have a division sign or a multiplication sign, I can pull it apart. So rather than writing square root of 16 over 2, which is still not really useful, I can rewrite this as square root of 16 times the square root of 2. And that's why it's important that we find that perfect square that goes into it evenly, because who knows the square root of 16? Quick. 4. So this is going to simplify down to 4 square root of 2. My advice to you is right now, you're going to ask yourself, is there a perfect square that goes into this evenly besides 2? I mean, 2 is not even a perfect square. So you have this as simplified as possible. Always ask yourself that. Because you may have put 4 in here, and you may have thought you had it completely simplified, but 4 would have went into it again. So at this stage, you want to ask yourself, is this fully simplified? Is the square root of 2 fully simplified? It is. So then you go on to your next problem, which is square root of 216. Can someone tell me what perfect square goes into 216 evenly? Brian?
4.
4 does? Absolutely. Is there anything bigger that goes into it? Let's just do 4. Let's do 4 to see what I meant on here. So how many times does 4 go into square root of 216?
54.
54. So we could rewrite this as a square root of 4 times 54. So this is just if I did the first thing that came to mind. Well, that's just going to equal square root of 4 times square root of 54, which is just going to equal 2 times the square root of 54. Now you're going to ask yourself, is there a perfect square that goes into 54? Because 54 still seems like a pretty large number, yeah. 9 goes into it? Okay, so we just realized that 9 also goes into 54. So I probably didn't pick the biggest square, perfect square that I could have, because 36 actually goes into it. But this is a great example of why you need to check that this is fully simplified. So 9 goes into it. So that means I can rewrite this as 2 times the square root of 9 times 6, which equals 2 times the square root of 9 times the square root of 6, which just equals 2 times 3 times square root of 6, which equals 6 square root of 6. All right, so if this number ever seems too big, if it's like, wow, 54 seems pretty big to be completely simplified, just go through your checks again, see if 54 is divisible by 4, 9, 16, so on and so forth. Okay? So just because you did it once doesn't mean it's fully simplified. You might have missed the fact that 36 went into that evenly. Are you going to get points taken off for doing that? No. You'll get points taken off if you just stop here. All right, but if you just go here and say that's a pretty big number, I'm just going to double check that Mr. Payton isn't trying to trick me. And it is a really big number, but sometimes another number might go into it. Okay? Does that make sense? That you should check even when you get done that a perfect square doesn't go into it evenly. All right, our next one is square root of 14 squared. Who knows what that equals? I'll go through why it equals, but who knows what it equals? If I just have square root of 14 and I square that baby. Yeah. It's just going to equal 14. The square and the square root are going to cancel out. And I'm just going to show you why. If you knew that off the top of your head, then you're probably fine. But I could rewrite this as the square root of 14 times the square root of 14. Well, if I can pull these guys apart here, I can also push them together. So I can rewrite square root of 14 times square root of 14 as square root of 14 times 14, which just equals the square root of 196, which just equals 14. I don't expect you to show me this every single time. All right, I do want to show you why it's true if you haven't done it for a while. All you need to know is that this square and this square root are inverses of each other and they cancel each other out. So most of the time, what I end up doing is I just say, well, I have a square root of 14 squared. I usually just cross those two things out and just say they're inverses. I'm left with 14. Or I'll write this and say, oh yeah, they just equals 14. All right? If you want to, you can do all of the steps. Just like this, you can do all of the steps. If you're confident about it, you don't have to show me all of the steps. Show me enough that if you got it wrong, that I knew at least what you were doing. All right, our next one is 5 times the square root of 7. Well, the first thing I'm going to do is I'm going to rewrite this. I'm going to rewrite this as 5 square root of 7 times 5 square root of 7. Well, in fact, this is 5 times square root of 7 times 5 times square root of 7. Do we have some kind of property that lets us move around multiplication? If I have chain of multiplication, I can just move stuff. Does anyone remember the property? Kind of multiplication, yeah? Commutative property. The commutative property of multiplication means that basically 5 times square root of 7 times 5 times square root of 7 can be rewritten by the commutative property of multiplication as 5 times 5 times square root of 7 times square root of 7. Well, 5 times 5, that's easy. That's just 25. Square root of 7 times square root of 7, that's just square root of 7 squared. But hang on, those just cancel out. And we're just left with 25 times 7. Well, 25 times 7, that's just like having 7 quarters. It's almost 8. It's almost $2. But it's going to turn out to 175. All right, so that's the easiest way to do the ones that are squared like this, is just to put your numbers that don't have a radical next to each other and the ones that have radicals. So we're going to do that exact same thing on this next one. I can't do much with 3 times square root of 7 times 5 times square root of 12 unless I can see that I can rewrite this as 3 times 5 times square root of 6 times square root of 12. Once again, that is a commutative property. Well, 3 times 5, that's easy. That's 15. I'm going to push together the square roots, so we're going to have 6 times 12. Well, that's going to give me 15 times the square root of 6 times 12. Well, that's 60 plus 12, so that's going to be 72. Square root of 72, is that completely simplified? Do any perfect squares go into that baby? No? 9? 9 does. Does anything else? 4 does. 36. I'm always looking for the biggest one. And it is 36. 36 is the biggest perfect square that goes into it. If you use 9, if you used 4, the only thing that's going to change is you're going to do another simplification process. Okay, so if you use 9, you would have came out and said, hey, that's still a pretty big number. Let me see if the perfect square goes into it. Okay, and you'd realize 4 goes into it. All right, if you used 4, you'd be like, that's still a big number, because 72 divided by 4, 6 would go back into it. All right, so I'm going to use the biggest one possible, and that's 36. So I'm going to have 15 times 36 times 2. Well, that's just going to be 15 times the square root of 36 times the square root of 2, which is just going to equal 15 times 6 times the square root of 2, which is just going to equal, well, 6 times 15, that's 60, plus 30 equals 90 square root of 2. And like I said, I don't expect you every single time to write out every one of these. If that helps you get the correct answer, do it. Write it all. Don't try to skip stuff. If you're one of those people that make mistakes all the time, like I do a lot of the time, write out every single step. So at least that way, if you get it wrong, Mr. Baby can follow every one a bit of your thinking, and I can be like, oh, they just multiplied 15 times 6 wrong. Versus someone that went from here to the answer, and I'm like, I have no idea how they got it wrong. All right, you're going to lose a lot more points. All right, last 3. What's wrong with number 7? The thingies on the bottom. That's very mathematical of you. Yeah, the radicand is the one on the inside. So, yep, is in the denominator. So our radical is in our denominator. Or that thingy's on the bottom. I don't care. I really don't care. Because on the test, I'm not asking you, why is it wrong, right? As long as you recognize that this can't be here, I'm okay with it. How do I get rid of a square root of 2? We could square it. There's an easier way though, because squaring will work here. I could square this whole thing, but then I need to square the other side. I don't have another side, so I can't square both sides to do it. How can I turn square root of 2? What can I multiply square root of 2 by? Let's just go with that. What can I multiply square root of 2 by in order to turn it into something that doesn't have a radical? Massive? I'd multiply by square root of 2. So I can multiply this bottom by square root of 2, because square root of 2 times square root of 2 equals 2.
You were trying to get the top.
I'm trying to get this gone. I'm just trying to make this. I'm not worried about where it's going to go. I'm just worried about. I'm not done with this problem, but I'm just worried about, well, what's square root of 2 times square root of 2? Yeah, no, you're right. It's 2. It's 2, because that's going to equal, let me leave this here. It's going to equal square root of 2 squared, which is just going to equal 2. So we're fine. So whenever you have a radical on the bottom, you're just going to multiply that bottom by whatever radical you have. Am I allowed to just multiply by a number, though? Can I multiply anything by whatever number I want to? No, you can't. So to keep this equation balanced, you're going to also multiply the top by square root of 2. Because that way I'm multiplying by square root of 2 over square root of 2, which is multiplying by 1. I think I'm okay multiplying by 1. It doesn't change anything. Right? Table times 1 is still table. I don't have 2 tables. I just have 1 table left. So I'm really just multiplying by 1, which means I have 3 times square root of 2 on top, which means I really have 3 times square root of 2 over 2, and that's 100% fine. I no longer have a radical in my denominator. All right, square root of 4 over 7. I cannot have a fraction underneath a square root. And this is okay. If it's just in the numerator, it's okay. It's only if it's in the denominator or if it's covering the entire fraction do we have a problem. All right, we have a problem. We have square root of 4 over 7. Just like with multiplication, I can break this apart and rewrite it as square root of 4 over square root of 7. That looks more manageable. Because I know the square root of 4 is just 2 over square root of 7. What am I going to do to get rid of that square root of 7 in the denominator? Grace?
Multiply both the numerator and denominator by the square root of 7.
Absolutely. So we're going to multiply the top and the bottom, or numerator and denominator, by square root of 7. So multiply the top by square root of 7, multiply the bottom by square root of 7. And the awesome thing about square root of 7 times square root of 7, that just turns into 7. And the top is 2 times square root of 7. I no longer have a radical in the denominator. I'm also just going to real quick, is there a perfect square that goes into square root of 7? Does 4 go into it? Does 9 go? Oh, 9 can't go into it. Wait, no, I'm good. That's my finished answer. All right, so I'll always do that check. Do I have a radical in the denominator? Is there a perfect square that goes into that number that's underneath the square root? All right, our number 9. You could have solved this in a multitude of different ways. All right, you could have simplified stuff. I'm just telling you that if you already did this problem and you did it a different way, just make sure we came up with the same answer. There's multiple ways to do this. What I did is I went ahead and I said, I'm going to get rid of that radical on that bottom, right off the bat. Because I know that's got to go bye-bye, so I'm just going to get rid of it right away. And then we'll see what we can simplify from there. So a square root of 24 times the square root of 24. What's that going to give me? Square root of 24 times square root of 24? Anybody? Shout it out. I heard you already. More people? More people? 24. Okay. So we have 24 on bottom. And on top we have 4 times square root of 3 times square root of 25? No, 24. Yeah. Yelled at myself. All right, so let's come down here and we'll say that equals 4 times. What can I do with that square root of 3 and that square root of 24? because I can't do much with it right now. I just talked to you, or talked to someone else. What can I do with the square root of 3 and the square root of 24, Brian?
Multiply them together.
Multiply them together. Underneath that square root, right? So we're going to have a square root of 3 times 24. All over 24. Keep going, keep going, keep going. I have 4 times, well, 3 times 24. Well, 3 times 2 is 60, plus 12 would be 72 all over 24. Cool, cool, cool. We could simplify, or I'm going to deal with the radical first. All right, I'm just going to leave everything the same. I'm just going to deal with the radical. What perfect square goes into 72, and what's the biggest? Because there's a bunch that go into what's the biggest? 36 goes into it. So I can rewrite this as 4 times the square root of 36 times the square root of 2. Buzz you. Over 24. Well, that equals 4 times 6 times the square root of 2 over 24. That equals 4 times 6 is 24. Uh-oh. Over 20. What's 24 divided by 24? 1. So to simplify this, I would just cancel those guys out. Equals square root of 2. So all of this simplified right down to square root of 2. And that's why simplifying radicals is important. Because if you're an engineer and you have to rewrite this number over and over and over, wouldn't you rather use this than this? Especially if you've ever coded anything in your life, you want to keep it as simple as possible. You don't want to have a whole bunch of these running around. You want a whole bunch of these guys running around. It also alleviates some strain on computers, especially when you have a huge program.